I'm building a game about urban transportation, so I've started studying how cities work. Having lived in a city all my life, I've forgotten how beautifully intricate they are. As William Gibson once put it, a consensual hallucination experienced daily by billions of legitimate operators, in which humans and machines moving within a highly parallelized runtime thread an NP-hard labyrinth of optimization and scheduling problems. And yet for millennia, humans navigated deserts and seas in networks as complex as cities, long before the concept of an algorithm arrived. The artifacts they left behind are our lens into how these systems functioned. "5,000 years ago, a particularly remarkable civilization emerged in what is now southern Iraq, the Sumerians of Mesopotamia. Positioned between the Persian Gulf and the Mediterranean, writing emerged out of necessity, a means to record and regulate an increasingly complex web of trade and commerce. From the archives of the great trade hub of Ur, a copper merchant named Ea-Nasir left behind hundreds of clay tablets containing complaints and frustrations from customers, a relatable phenomenon that transcends time and culture. One such letter reads, "When you came, you said to me, I will give fine copper ingots, but you have not done so. You put ingots that were not good before my messenger, and you said, if you want to take them, take them. If you do not want to take them, go away. What do you take me for that you treat somebody like me with such contempt?" Records like these reveal not just poor service, but the fragility of long-distance trade. They remind us that Ea-Nasir stood at the very end of a vast and unpredictable supply chain that reached far beyond Ur. Copper wasn't mined anywhere close to Mesopotamia. It had to travel 1,400 kilometers first from the mountains of a distant land called Magan. In the Hajar Mountains of Oman, the people of a Bronze Age society called the Umanar mined copper and smelted it in mountain furnaces, refining ore into copper ingots that would later circulate through Mesopotamian markets. Remnants of these furnaces and nearby settlements remain today, along with pottery, bronzewares, and art that testify to a thriving culture of merchants, miners, and sailors. Simple merchant vessels with shallow hulls could easily navigate the calm, sheltered waters of the Persian Gulf, carrying cargoes of copper ingots from the Hajar to trading hubs like Ur, a relatively vast distance comparable to that between London and Rome. Depending on the route and conditions, the journey could take anywhere from 3 to 6 weeks, and at the height of the Bronze Age, dozens of ships made the voyage each season, forming a steady flow of goods and resources. The most direct route sailed from the Hajar coast, through the Gulf of Oman, across the Strait of Hormuz, and northward up the Persian Gulf to Ur. But more often, however, ships hugged the coast, stopping at island trade ports like Keshem and Bahrain. And when the seas made navigation difficult, merchants turned inland, joining overland caravans that crossed the desert instead. Each route serves a different balance of time, cost, and safety, together ensuring the flow of copper that connected the mountains to the cities of the plain. Taken together, these routes form a network. Ports and oases as nodes, sea lanes, and caravan tracks as the edges binding them together. Reduce the geography to its structure, and the Persian Gulf becomes a weighted, directed, multi-dimensional graph, each dimension representing a different variable: spatial distance, travel time value, risk, slices of a single dataset that had to be intimately and implicitly understood by the merchants of the ancient world, off nothing but the position of the stars, the patterns of the wind, and stacks of clay tablets. From this elevation, new semantics begin to emerge. The language of nodes, edges, and weights fall neatly into place when describing seemingly unrelated concepts like trade routes and supply chains. And it becomes evident where new lines can be drawn to bridge gaps and optimize flow. Yet the same problems and opportunities begin to also resemble more familiar systems like urban transit networks. And just like the trade routes of the ancient world, urban design is constantly evolving out of necessity. Transit lines must react to a live environment as populations and demographics expand, and the structured language of graphs provide a framework in which these changes can be modeled and reasoned upon, but most importantly, interacted with, played with. Playing with the graph uncovers deep insights that cannot be passively absorbed. It's how humans from early childhood develop intuitions and instincts about the relationships between cause and effect. The act of tipping over a stack of blocks is not so different from optimizing a complex maze of transit lines because both activities involve interacting with a sandbox in a non-destructive way, observing a reaction, and then measuring an outcome. Every toppled tower is a test of gravity, and every rebuilt structure is a new hypothesis. This process doesn't disappear with age, we simply substitute toys with complex simulations called video games. Play unravels complexity. It reveals emergence, patterns and behaviors greater than the sum of their rules. Each interaction becomes an experiment, a way to probe the boundaries of a system and watch it explain itself. And games, defined by rules and mechanics, expose a unique surface in which we can interact and experiment and play. If mathematics is the language of nature, graphs are among its clearest expressions. They formalize trade and transit alike as networks of nodes and edges, revealing bottlenecks, redundancies, and optimization opportunities. And playing with them reveals as much about complex systems as it does about ourselves. What other mathematics remain hidden in plain sight? And what futures might emerge when we learn as we always have, by playing.